So in this case, we are going to consider a typical exam revision as we had our introduction. Remember, we managed to work with the nature of roots. This is part of your equations, guys. So you need to understand the nature of roots as we listed previously, what is important according to the question papers that you're going to be answering. So I described especially what is important, guys, is the delta, this part of what? B squared minus 4AC. It is very, very important because it is not always where you are given an equation x squared minus 5x plus 6 is equal to 0. Then they'll ask you to give or to state the nature of roots. It's not always like that. You can have conditions like this question that we are having here, where they have expressed something. If f of x is equal to 0, they are telling you f of x, remember, that's a function, something that you had, we do not know. Is it in the form of ax? Is it this way? Is it ax squared plus bx? Is it ax squared plus c? But what we just understand is a quadratic because of this part here when it was to be solved. So the highest exponent is what? Is 2. So we are given that this f of x that we are given, which is our quadratic, is equal to what? Is equal to 0. If a quadratic equation is given, like this is equal to 0, x is equal to this. Guys, they are telling us a lot of things here. This is what? An equation. Once you say it is equal to 0, so you were solving a quadratic equation, isn't it? X is equal to what? Minus b plus or minus the square root of b squared minus 4ac, everything over 2a. You were solving the equation. So this is what you had. Here's roots. X is equal to minus 5 plus or minus. This is the part of our quadratic formula when you were solving a certain equation that you do not know, but that we do not know like now, but we know it was a quadratic. So they are saying, for which values of k will the roots be equal? So guys, already the answer is here. The answer is here. That is where we have our answer here. Why am I saying so? Because we know when we are working with the nature of roots, what affects us on the nature of roots is our delta, the part of b squared minus 4ac. The part of what? B squared minus 4, this one. B squared minus 4ac. Remember, that is our delta. In our simplification, we said the delta is equivalent to what? B squared minus 4ac. So the b squared minus 4ac is the part that we have under the square root here. So they have simplified this for us. Already they simplified, guys, your delta. They are telling you that this is your delta here under the square root. 3 minus what? Minus 12k squared. They're already telling you that. You already have that. So what is it about the delta if our roots are what? Equal. That is where our question is now. For which values of k, because this is your delta. So for which values of this k that the roots will be equal now. So let's go back to our notes. What is it when the roots are equal? Which condition that gives us equal roots according to what we listed before? Equal roots. We can see that only the part where we have equal here is when our delta is equal to 0. Only that part. We do not have this one, it's unequal. This one, it's unequal. There we do not have any roots there. But when it is exactly equal to 0, we can see that that's where the roots are equal. So meaning to say, for us to have equal roots, our delta here, which is our discriminant, must be equal to 0. So we are going to take this so we are saying for what? For roots to be equal, for roots to be equal to 0, that means our delta, for our roots to be equal. For our roots to be equal, as we are given, our delta must be equal to what? Our delta must be equal to 0. So therefore, we're going to take this, equate to 0. 3 minus 12k squared is equal to 0. We have formed an equation. This one, it's an equation. It's not an inequality. We are having exactly the value of k to be determined there. We are not going to have a condition where we are saying k is greater than this or k is less than. No. There we are going to have exactly the values of k or the value of k, like we are given here. All right. So let us solve, guys. We can take the 3 to the other side. It's going to be negative. So that's negative 12k squared is equal to 3. To the other side is going to be what? Minus 3 here. Just subtract 3. So that's 0 minus 3, which is minus 3. We can see that this is minus 12k squared. There is a constant. Why am I actually taking this? Because we have a quadratic, but this quadratic, as we can see that we do not have like the format ax squared plus bx plus c, where we can have k squared and this one can be k. We do not have that condition. It's only 1k. So we can take this to the other side, then divide by what? By negative 12, by negative 12 like this. So it means your k squared is equal to what? Just use your calculator here. That is going to be 1/4. So this is your k squared. So if k squared is 1/4, what about k? We have to get rid of the square. So introduce the square root both sides, knowing that we are solving a quadratic equation. The square root of any number is what? Plus or minus. So that's going to be plus or minus 1/2. The square root of what? The square root of 1/4 on your calculator. That was going to give us what? 1/2. But knowing that at a square root plus or minus, we've got what? 2 answers that you're going to have on your simplification. So that is what you have there. So you can simply use your calculator, guys. 1/4. The calculator gives you only one value, but you're supposed to know what are you working with, guys. All right. So these are the values of what? Of k. K can be positive 1/2. It can be negative 1/2. For us to have what? Equal roots. So you see, they can give you a part which is already solved. Just like here, what we are given on this part. The roots of the equation, again, f of x is equal to what? 0. A certain equation that we had to solve. So once you're given x is equal to this plus or minus, we know it was taken from what? A quadratic formula. There's no way. So this whole part is the one that we need, that is under the square root, our b squared minus 4ac, our delta, this one. This is the part that answers your question. Wherever you see any other part of m, do not consider the focus on the delta. What is under the square root? Yes, we can see there's another m here. Don't focus with that one. Leave it like that. It has nothing to do with our question. So our question is, determine the values of m for which the roots will be non-real. Meaning to say, if we are to solve this equation, we are not going to have any solution there. Non-real. They do not exist. This is a condition. Maybe we've got plus or minus the square root of a negative there. So what is it about being non-real when we've got a negative under the square root? Our delta in this case is less than 0. That is the condition, remember. When we have non-real roots or imaginary roots, our delta is negative. That's less than what? Less than 0. So this is the condition that we are going to answer using our question. Our delta must be what? Less than 0. And this is the part of our delta here under the square root, which is the 16 minus 4m into what? Minus m plus 5 like this. So we are saying this is less than 0. Guys, this is different to what we had previously here. We formed an equation because we are saying it is exactly equal to. It is exactly equal. There we are saying it is less than. Once we have got this sign, guys, we are back to the inequalities. So this time we do not have an equation. We've got what? An inequality. So you're supposed to solve an inequality. So depending with the type that you're going to have, is it going to be linear? Is it going to be quadratic? So you see that after expanding the brackets and simplifying further, that is it linear or quadratic? So this is it, guys. This is our minus m plus 5. This one, we have to expand this bracket by what is outside of the bracket, which is the minus 4m. So it's going to be 16 minus 4m and minus, you multiply that one, take note. So it's negative to a negative, which is going to be what? Positive. So that's 4m squared. M and m, that will be m squared. We do the same thing, the minus 4m to this plus 5. So it's minus to a plus, that's minus. So it's going to be 20m. All right, so that's less than 0 like this. This is what we have. An inequality. Guys, we are back to inequalities. This is no longer about the nature of roots. To say, I was doing nature of roots as a topic. No, it has changed. Because what you need to solve here is an inequality. How do you solve your inequalities? Remember your format. Ax squared plus 1. So here we're dealing with what? With the m. So you can write as am squared plus bm plus c is supposed to be less than 0, as we've got what? A less than there, which is the format. We find our critical values as usual because it's now an inequality, guys. All right, so let's just rearrange. This is 4m squared minus 20m. Okay, take the 16 at the end, our constant. That's less than 0. So we can simply divide by what? By 4, by 4, by 4, the highest common factor. The highest common factor. So cancel this. That's m squared. Minus 20 and 4 is going to give us what? Negative 5m. 16 divided by 4, that is 4. All right, so this is less than what? Less than 0. So as we can see, guys, we have our quadratic inequality. That's a quadratic. The highest exponent is what? Is 2. So finding of the critical values, we can factorize. First, that's less than 0 here. So let us factorize and see. Since the coefficient of m squared is 1 here, since the coefficient of m squared is 1, it simply means we are going to have m and m. No adjustments there. So just focus on the constant, which is what? 4, positive 4. We need the products or the factors of positive 4, but these products must add up to what? Negative 5. So which numbers, guys, are we going to take? Two numbers, you multiply them, they give you a positive 4. But when you add, you must get a negative 5. So there is something about 4 and 1 there. But to get a negative 5, we must have what? Negative 4, negative 1. Multiply these two, that's a positive 4. Add these two, that's a negative 5. So we need negative 4 and what? Negative 1. All right, so that's a negative 4 and negative 1. So therefore, our critical values can be determined. The minus 4 to the other side was going to be what? A positive. So m is equal to 4, or our m is equal to what? Negative 1 to the other side was going to be what? A positive 1. So these are your critical values that you're going to use now to determine the exact solutions. With the method that you are capable of, guys, are you going to use the number line? Because these are inequalities. Forget about the nature of roots. How do you solve the inequalities? All right, I explained all the methods, guys. So in this case, I'm just going to use the graphical method. Remember, from our graphical method, the coefficient of m squared, this one, just like we have ax squared plus bx plus c. Remember, a determines the shape. If it is positive, this one is positive. Our A is greater than 0. So we're going to have what? A smiley shape like this. So that is the condition of the shape. All right. The A there on M squared, the coefficient of M squared is on the shape. So these are the critical values, your solutions, meaning to say this is just like our x-axis, but we are solving for M. So this is the axis what? For M. This is the M axis, where M is 1. Another one is what? Is 4. Guys, 1 is less than 4, so 1 will be on the left. So this is it. So where do we have this function of M, this whole function here of M that we are solving, like because the quadratic here, where it is less than a 0. Less than a 0, I said this is below the x-axis. In this case, below what? The m-axis, below this line. So below, according to the shape that we are talking about here, down here. So we are going to take what is in between the curve. What is in between this one? This is where you get your solution. Okay, let's go back to our introductions, guys. All right, that's it. So therefore, we can conclude that when it is in between, our M must be greater than the smallest value, which is 1. So M is greater than 1, but what? But the same M is less than 4. M is greater than 1, but less than 4. This is the condition. Remember, on our question, we do not have an equal to. On our inequality, there's no equal to. If there was an equal to, meaning to say you're going to put that equal to, but we do not have that. So this is going to be your final solution to this inequality that you're given. These are the values of M, meaning to say the M that we are talking about here. Let's go back to our question. The M that we are talking about, the values of M for which the roots will be non-real. The values of M is any value, any in between these values from 1 to 4, in between, not 1. In between, meaning to say we can try M, let's just talk about integers. We can try 2, 3. These are the only values in between 1 and 4, 2 and 3. If M is 2 or if M is 3, we are not going to have a solution. We are saying it will be non-real. All right, guys, this is for the purpose of revision. So let's just do this. Remember, we are saying our M is what? Greater than 1, but less than 4. So let's just take any value there in between. Let's say M is 2 or M is 3. These are the only values in between 1 and 4. You cannot take 1. You cannot take 4. Those are your critical values. They are not part of your solution. So let's substitute here in place of M and C. If we are going to have a solution, guys, let's see. All right, this is our calculator. So let's take this one. All right, just gonna use if M is 2. So we are given that X. All right, so let's just simplify what is under the square root so that you can see this, guys. 16 minus, that's 4 times M. All right, let's just hope it's not gonna affect. Remember I said when M is 2, then we open a bracket, that's minus M, which is minus 2 plus 3, like this. So this is a bracket. All right, let's just stop. Our BODMAS there is fine. No, our BODMAS is not okay. Our BODMAS is not okay. All right, let me just do this way, calculator part. 16 minus 4 into M, which is 2. Then we have got minus, this is M, which is 2 plus what? Plus 5. So this is going to be 16 minus, all right? This is, here you combine these two, this one. It's one part. So it was going to be 8 into what? Minus 2 plus what? Plus 3. So it was going to be 16 minus 8 into what? This one, you combine this, all right? This is what? 5. Why am I getting the answer already here? This is a 5 here. This is a 5. Okay. So this is a 5 here. So this is minus 3, minus 2 plus 5, which is 3, which is 3 like this. Okay. So you have to be careful there. This is 3, this one. So it's going to be 16. Then you multiply these two. 16, 8 times 3, which is what? 24, 8 times 3 plus 24. But it is having what? A negative. So this is negative 2, 4. Then 16 minus 24 like this. That's minus 8. All right. So this can make sense. This is negative what? 8. So this is it, guys. What is under the square root? This one, the number under the square root is what? Negative 8, like this. So it simply means we've got something like this. X is equal to 4 plus or minus the square root of what? This part we simplified, we got minus 8. Everything. When m is what? I substituted this one when m is 2. So meaning to say in the denominator, you're going to substitute a 2. So that's over what? Over 2 times 2, which is 4. This is what you're going to have. When you substitute m, which is what? Which is 2. In place of m there, you substitute what? A 2. This is what you're going to have. Under the square root. All right? Sorry for that. That is under the square root. So meaning to say, guys, if this is the part that is representing m here, I mean the part of what is under the square root. And we wanted to simplify now to find our answer to say 4 plus. We're going to say the square root of what? Minus 8 over what? Over 4. Then you see, met m. We do not have any solution there. It is because of what? The negative here under the square root. Our values mathematically, they do not exist on that condition. They do not exist. So that's the condition that you're working with there. They do not exist. So this is what I'm trying to say, guys. For these values, if m is 2 or 3, so meaning to say this is exactly what we needed, because they are saying the roots will be what? Non-real. They do not exist. So if our m is in this interval, guys, that is exactly what we needed. So here it's not about the justification of the question. It is about understanding exactly what you are working with, guys. So that when you're answering these questions, you have an idea of what exactly you are working with. So let us meet again in another questions to be answered again on this platform. So make sure that you work out as many questions whilst you're waiting for other question papers to be done and revisions. Maybe you've got a specific question that you have. The comment section is there. Let's communicate so that we can work on those questions. That's it till we meet again.